let's talk about interior angles of a polygon. So here I have a pentagon, which has 5 sides. This is not a regular pentagon, which means that the angles and the sides are not all the same measure. They are different. But I have taken this pentagon and I have divided it up into 3 triangles, which you can see here. So this triangle on the left, I have these 3 angles, which add up to 180 degrees. In the middle triangle, I have these 3 angles, which add up to 180 degrees. And on the right side, I also have 3 angles that add up, you guessed it, to 180 degrees. Now, it's a 5-sided figure, and we cut it into 3 triangles. Now, you can experiment with any polygon you want to, but you're always going to find that the number of triangles is always 2 less than the number of sides in the polygon. So what that means is that all of these angles that we have marked from these triangles, which encompass all of those interior, every interior angle of the pentagon, we can find it by finding the number of triangles, which is always going to be the number of sides minus 2 times 180 degrees. That is our formula for the sum of the interior angles of any polygon. So in this case, it will be 180 times 5 minus 2, which is 3, which is going to be 540 degrees. Now, for regular polygons, and this is a regular pentagon, we can also use that information to find a new formula, to create a new formula, which is the number of angles in any one single interior angle. Because this is a regular shape, all of those interior angles are going to be the same. And it's really pretty intuitive. You take the sum of all of the angles and you divide it by how many interior angles there are. 180 n minus 2 divided by n. So in the case of the pentagon, we're going to take 185 minus 2 divided by 5. We know from the last slide that 180 times 3 is 540. We will divide that into 5 pieces, and we will get 108 degrees for each interior angle of the pentagon, and that's always going to be true for a regular pentagon. So here's another example with a different shape. Find the sum of the interior angles of a regular nonagon, which has 9 sides. Whoops, there we go. And the measure of a single interior angle. Well, we're going to go 180 times 9 minus 2. So, of course, it's 180 times 7. And if we drew a nonagon, we would see 7 triangles. 7 times 8 is 56. So this is 1260. And we will divide that by 9 to get the measure of one single interior angle. So 180 times 7 divided by 9. We'll go 1260 over 9. There's 1. That's going to give us 36. So 140 degrees for the measure of a single interior angle. We will make another video for exterior angles, and then we'll also do another one with some example problems that go a little bit deeper than the surface level that we explored here. So I will link those videos in the comments. Thanks for watching. Take care.